Hey guys, welcome to video 3. Today we'll be talking a little bit about adding fractions. And this is pretty simple once you get the hang of it. It's just a few steps. We're going to first talk about adding fractions with the same denominator and then with a different denominator. Before we start that, let me make sure you guys know there are two ways to turn in your assignments. One is obviously to print it out, do it, turn it back in. The other one is just write your answers on a Google Doc and share that to me. Either one works. And I'm saying that because, quite frankly, I'm getting the same question over and over again, and I'm just here to give you guys a statement. Hopefully you know. And also, there's some of you who haven't even logged in. Obviously, you can't see this, but if you have any friends who haven't managed to get into Google Docs, please make sure that you call them up and tell them. You guys know your friend's situation with the internet or anything better than I do. So if you have a friend you think, hey, maybe this person hasn't gone out to Google Docs yet, maybe ask your friends from our class. Hopefully you can help them out. Great, and with that, let's start with fractions. First of all, little review. The top number of a fraction, probably somewhere over here. We don't have a whiteboard, so this empty space is our work zone. The top number is the numerator. Numerator has a u in it, and it's the number that's up there. That's the main number we're going to be looking at when we're adding. The bottom number is the denominator. That's the number that's down there. Denominator starts with a D. That's the number that we'll be looking at to see how many parts total. And the middle line is the fraction bar. That's how you know it's a fraction. After that, numerator, denominator. Now if the denominator's 2, we call it halves. If it's a 3, thirds. Fourths, fifths, sixths, sevenths, eighths, ninths, tenths, 11ths, 12ths. Obviously some of those we don't even bother doing in class, but now you know the names. The ones obviously we do handle are 2, 4, 3, 4, 5, 6, 8, 10, and 12. I believe those are the ones we handled. Yes. Those are the most common ones and the easiest ones to deal with. So, let's add fractions. Say they have the exact same denominator. Say it's 1/3 plus 2/3. That's pretty simple. The denominator stays exactly the same because the number of different parts, in this case 3, as in thirds, does not change. We add the numerators together. So if it's 1/3 plus 2/3, that's 1 plus 2 equals 3, so that's 3/3, or 1 whole. Same way, 1/4 plus 1/4. Denominator stays the same, it's a fourth. 1 plus 1 equals 2. 2/4. Pretty self-explanatory. Let's look at one of the things that you actually had to do for this. That's not the correct one. There it is. So what if we have something a little bit more challenging? Something like, I don't know, let's see, 10/12 plus 12/12. Well, same thing. The 12 at the bottom stays the same. The denominator stays 12. And the top numbers, 10 plus 12. So what is 10 plus 12? Well, if you use your calculator, count it on your fingers, or just simply use your brain, you'd understand that 10 plus 12 equals 22. So you got 22/12. If you write it as a mixed number, that is 1 and 10/12. 1 and 10/12. If it's the same exact number at the bottom at the denominator, it's pretty simple. Just add the numerators together. Now, what if we're stuck with gasp and egad? Shock horror, what if they're different denominators? Well, it's a simple process too, because we just have to basically change the denominators to the point where they're the same. How do we do that? Well, let's look at one of these. Number 7 on your worksheet is 1/2 plus 1/3. That's a good basic one to start with. So, how do we change the denominators to become the same? You can't just change the 2 to a 3 or 3 to a 2. It's not going to be the same. And you can't just straightforward add them, because that would be 1/6. 1/6 is smaller than both 1/2 and 1/3. Remember, I talked about this. The bigger the denominator, the smaller the individual pieces. That way, 1/6 is actually smaller than 1/2 and 1/3. That's not how addition works. So, gotta figure out a way to turn 1/2 and 1/3 to have similar denominators so you can add on through. How do I do that? Multiplication. No, we're not multiplying them. So, here's the rules. Rule number 1. The denominators have to be the same. We've covered this. Rule number 2. Whatever you do to the denominator of a fraction, you have to do the numerator of a fraction in order for them to be the same. And rule number 3, and we've covered this, the bigger the denominator, the smaller the actual individual fraction is. 1/6 is smaller than 1/2 or 1/3. So, let's apply rule number 2. Let's take 1/2 plus 1/3. How do we do this? Well, like I said, whatever you have to do to the bottom, you have to do to the top. This is when we need the greatest common factor. The greatest common factor is a magical number. Actually, greatest common multiple. Actually, sorry. Least common multiple. Wow. I'm having a rough day. Least common multiple. Least common multiple is a special little a special little number that you get when you multiply the denominators. It doesn't always have to come out that way. Sometimes you don't multiply the denominators and you actually end up with a number that they just have on the list. So, what are the multiples of 2? 2, 4, 6. Let's stop there, because 3 is 3, then 6. Oh, look at that. We found they have a 6 in common in their list of multiples. So, let's look at 1/3 first. What do we have to do to turn a 3 into a 6? That's right, we multiply by 2. So 3 times 2 equals 6. But remember, rule number 2, whatever we do to the bottom, we have to do to the top. So 3 times 2 equals 6, then 1 times 2 would equal 2. So then we have 2 over 6. Let's shelve that for the side. Let's look at 1/2. 2 times 3 equals 6. See what we're doing here? We're changing them. And then 1 times 3 equals 3. So 1/2 would become 3/6. Let's bring that other one over. 2/6 plus 3/6. Oh, magical day. They have the same exact denominator. Now you can add on through. The 6's remain the same, so the denominator is 6. What is 3 plus 2? 5. 5/6. If you need that explanation again, rewind, listen again. I'll give you a moment. Moment's up. Anyways, that's pretty easy. So, if you're trying to figure out what number to change the denominators to, list out their factors and find the first one they have in common. Some of them are a little bit simple, like 5 and 10. Obviously, that's 10. Because 10 is its own number, and then 5, 10. Boom. So you can just multiply that 5 with a 2 to make it 10. And then you have similar denominators. And your worksheets do come with the answers attached, but please do yourself a good service and actually practice it out instead of just copying off the answers, because I mean, yeah, you might get them right here, but you're going to end up messing it up in 4th grade. I'm saying 4th grade because, quite frankly, it's going to be kind of hard to do a test right now. Anyways, so, do we need to do another one? Probably a good idea. Let's do number 10, 1/5 over 1/2. So, what are we going to do to these in order to make them same? Well, we're going to list out their multiples. 5, 10. Stop there. Because 2, 4, 6, 8, 10. Look, they both have 10 in the list. So, 1/5. What do we have to do the 5 to make it a 10? Multiply by 2. 5 times 2 equals 10. Now do the same thing at the top. 1 times 2 equals 2. 1/5 turns into 2/10. Shelve that. Then we have 1/2. 2 times 5 equals 10. Then we gotta do the same thing to the top. 1 times 5 equals 5. 1/2 turns into 5/10. Bring it back. 2/10 plus 5/10 equals 7/10. You got it. Okay. Well, that's my video for now. Sometime next week, I'm going to give you guys a video on the rock cycle. And probably one on subtracting fractions, which is very, very similar, actually. You're just subtracting. You're still trying to turn the denominators into the same number, and you're still just subtracting on through with the numerators. Pretty self-explanatory, but I know some people will find it a little bit difficult, so I will put out a video for that. And we're going to start with a little bit of the rock cycle, starting with igneous rocks, which are also known as volcanic rocks. So, look forward to that. See you guys next week, and once again, I love you 3000.